Hello again, Algebra 2 people. After the last couple days of learning how to divide polynomials, today and tomorrow we're going to spend time talking about what we can use that polynomial division to do. And this is not so much like real-world applications of polynomial division, but more how we can use polynomial division to be able to do some factoring, to be able to do some solving, and things like that. So in section 5.7, which starts on page 29, we're going to start looking at a couple uses here. First thing we're going to do is we can use some division to determine if something is a factor. For example, I want to know, is x plus 3 a factor of this? I do not know how to factor this. If I did, I could just factor it and see, does x plus 3 show up as one of the factors? But I don't know how to do that. Unrelated, but not really question. 18. Is 6 a factor of 18? And why is 6 a factor of 18? Another question for you. Is 7 a factor of 18? And why? I hope you said no. I hope you said yes to the first question. 6 is a factor of 18, but 7 is not a factor of 18. And we can talk about this in terms of division. 6 is a factor of 18 because you can divide 18 by 6 evenly, and 7 is not because you can't do 18 divided by 7 and it doesn't divide in evenly. And what I mean by dividing evenly is if it divides in evenly, there's no remainder. And if it doesn't divide in evenly, there is a remainder. We can use similar ideas to figure out if a polynomial is a factor of another polynomial. How can I figure this out? Well, I'm going to go divide. I'm going to divide 3x to the third plus 10x squared minus x minus 12 by x plus 3. If it divides in evenly, that means the remainder is 0. And in that case, x plus 3, yes, would be a factor. If the remainder equals 0, then x plus 3 is a factor. So all I have to do is some division, and then I'll look at my remainder. Okay, if I just say divide, what would you rather do? Long division or synthetic division? I mean, I guess there's no wrong answer to that question, but I think synthetic division is going to be a whole lot easier and a whole lot faster. Negative 3 in the box. 3, 10, negative 1, negative 12. Let's go. Bring down 3, bring up negative 9. Down 1, up negative 3. Down negative 4, up 12, down 0. Because my remainder is 0, that means the answer is yes. X plus 3 will be one of the factors of this polynomial. That's all we're going to do. We're going to divide. If the remainder is 0, then yes, it's a factor. If the remainder is not 0, it is not a factor. So how about you try the next one? Letter A, is x minus 1 a factor of that polynomial? Well, I'll put 1 in the box. 3, 10, negative 1, negative 12. Down 3, up 3. Down 13, up 13. Down 12. Oh, this is looking good. Up 12. Down 0. Yep. X minus 1 is a factor. How about x plus 2? Do letter B. Negative 2 in the box. 3, 10, negative 1, negative 12. Down 3, up negative 6. Down 4, up negative 8. Down negative 9, up 18. Down 6. No, not going to work. Letter C, is x minus 4 a factor? 4 in the box. 3, 10, negative 1, negative 12. Down 3, up 12, down 22, up 88, down 87, up, calculator time. although I kind of see where this is going. I still want you to finish it off just to kind of prove to me your answer. I'm getting 336. That's all the proof that I need to say that no, x minus 4 is not a factor. Is something a factor? If there is a remainder of 0, then yes, it's a factor. If there's some other remainder, no, it is not a factor. Well, we can use this idea to completely factor some polynomials. Well, if I give you one. So for example, we're going to try to factor this cubic. No methods you already know of factoring will let us factor this. And I'm cheating a little bit by telling you what one of the factors is going to be. Here's what we can do to completely factor a polynomial. If you are given one factor, I am going to divide the polynomial by that factor. And then I want to rewrite the original polynomial as a product of the quotient, the answer we got, and the factor that I told you. I want to rewrite it as a product of the quotient and the factor that I gave you, and then factor what's left. If you're given one factor, we'll divide the polynomial, rewrite our polynomial as a product of the quotient and the factor, and then factor what's left. I got to show you how to do this. I'm telling you a factor of this cubic polynomial, x plus 1 is a factor, which means if I tried dividing by x plus 1, 1 in the box, 1, 2, negative 5, negative 6. Since I told you x plus 1 was a factor, my remainder had better be 0. If it's not, either I lied when I said it was a factor, or you messed up somewhere in the division. So I'm going to go and divide. I'm going to get 1, negative 1, 1, negative 1, negative 6, 6, 0, which gives me the polynomial x squared plus x minus 6. And actually, what I was saying over here is this original polynomial can be rewritten as a product of that quotient times the factor that I gave you. My factoring will look like x plus 1 times x squared plus x minus 6. Well, now we can keep going. We can factor what's left over here. That's going to give me x plus 1 times, looking for two numbers that multiply to negative 6 and add to 1. I'm thinking x plus 3, x minus 2. That original cubic can be factored into x plus 1, x plus 3, x minus 2. And that's the factoring. I tell you 1, you divide by that. We'll write our answer as, well, the answer we got from the synthetic division times the factor I gave you. Really, we're rewriting the original problem as that product. And then I'm just going to factor what I'm left with. This is my complete factoring. Notice we're not solving anything. This wasn't an equation. I can't solve it. I'm just rewriting it. Let's see what we can do with the next one. I want to try to factor this thing. If I tell you x plus 3 is a factor, well, negative 3 in the box, 1, negative 4, negative 9, 36. Do your division and give me the answer to the division problem in Edpuzzle. Down 1, up negative 3, down negative 7, up 21, down 12, up negative 36, down 0. So hopefully the answer you sent in was x squared minus x plus 12. Now I want to completely factor the original problem. So I can say my original problem is x plus 3 times x squared minus 7x plus 12. I bet you can finish this. Factor, and when you're done, make sure you're sending an answer using parentheses, of course, with 3 factors, not just the 2 from this one, but also make sure you're including x plus 3. Really, I need an answer I could FOIL and FOIL again to get the original problem back. What is your fully factored answer? And I hope you're going to say x plus 3 times x minus 3 times x minus 4. This is our fully factored answer. Go do the next one. And send in your fully factored answer to Edpuzzle. So I'm getting that answer of x squared plus x minus 2, along with the factor that I gave you. If I FOIL these, I'd get the original cubic back. I'm going to keep going. Of course, the order you write these in doesn't matter, but I'm thinking x minus 3, x plus 2, x minus 1. That is your fully factored polynomial. Next thing we need to look at. What if we're not just factoring, but solving entire equations? You know what? I think I'm not going to tell you what to do. I think we're just going to do the first one, and then we'll kind of write down what we're doing. For example, I want to solve this equation, and no method you already know is going to work. I can't factor out the GCF. Factor by grouping won't get me anywhere. I'm telling you x equals -1 is a solution. Well, let's start using some of the ideas we've already seen. If x equals -1 is a solution, what must be one of my little factors? If x equals -1 is a solution, that must mean that x plus 1 is a factor. And now, really, I'm just going to proceed the way I did before. I'm going to divide by that factor. -1 in the box, 1, -9, 11, 21. Down 1, up -1, down -10, up 10, down 21, up -21, down 0. I'm going to get that answer times the factor that I gave you. The only difference is now it's an equation. All you're going to do is you're going to continue factoring, but then, because it's an equation, you're going to set all the parts equal to 0. See if you can do that. Continue factoring. By the time you're done, you're going to get 3 factors, but then set each factor equal to 0 and tell me the 3 solutions. X plus 1, x minus 7, x minus 3 should be your 3 factors. When you set all the parts equal to 0, you get -1. Of course, you get -1. I told you it was an answer, but I do still need you to repeat it. Since this is a cubic, I need you giving me a total of 3 solutions. -1 is the solution, 7, and 3. Those are the 3 solutions. In general, to solve these polynomial equations, if I give you a solution, or a root, we're going to divide by the factor that gives that solution, use that to factor the polynomial, and then just solve what we're left with. If you are given one solution or one root, we are going to divide by the factor that gives that solution, and then we're going to use that factor to factor the entire polynomial. Like we did before, then solve what's left. Get that in your notes, please. I tell you an answer, You figure out the factor and divide by that, or really, I tell you an answer, that number goes in the box and we can kind of go. I'm going to factor the polynomial as far as I can, then I'll solve what I'm left with. Next problem. I'm telling you an answer, x equals 2 is an answer, which means x minus 2 is a factor. Take a moment, go do your synthetic division. I'll wait. So 2 is going in the box. 1, negative 6, 13, negative 10. Down 1, up 2. Down negative 4, up negative 8. Down 5, up 10, down 0. So I've got x minus 2 times x squared minus 4x plus 5 equals 0. Oh, wait a minute. I have a little issue here. I don't think you can continue factoring this. I can't come up with any two negative numbers that multiply to 5 and add to negative 4. Aha, but there's another way we can solve this. First of all, what's one of your answers? X equals 2. Of course it is, because I gave you that answer. As for this other piece, I'm going to go write out the little equation, x squared minus 4x plus 5 equals 0. You can't solve that by factoring. How else can you solve that equation? I hope you said quadratic formula. Yeah, we can use the quadratic formula to get our other two solutions. X is going to equal negative b, 4, plus or minus square root of b squared, negative 4 squared, minus 4 times 1 times 5, all over 2 times 1. This is going to equal 4 plus or minus the square root of 16 minus 20 over 2. 4 plus or minus square root of negative 4 over 2. 4 plus or minus, oh, they're going to be complex. How much fun. 4 plus or minus 2y over 2. I'm going to separate my fraction, 4 over 2 plus or minus 2i over 2. And I'm going to get 2 plus or minus I. We've got three answers here. We've got 2. We've got 2 plus I. We've got 2 minus I. Those are our three solutions. I'm going to divide, but what I'm left with might not be factorable further. If you can't factor it further, go use the quadratic formula to get your remaining solutions. How about you try the next one. So x minus 9 is a factor. I'm going to put 9 in the box and I'm going to divide. Remember, you'd better be getting 0 as a remainder, otherwise that wasn't actually a solution. And I'm going to get x minus 9 times 2x squared plus 8x plus 1 equals 0. No, if you try the x, you're not going to get anywhere with that. So, as far as this piece is concerned, quadratic formula time. X equals negative b, negative 8 plus or minus square root of 8 squared minus 4 times a times c all over 2a. Oops, all over 2 times 2. That's negative 8 plus or minus square root of 64 minus 8 over 4. Negative 8 plus or minus square root of 56 over 4. I think I can simplify. Negative 8 plus or minus square root of, I think that's 4 times 14 over 4. Negative 8 plus or minus 2 root 14 over 4. I might as well go and jump to my separated step. Negative 2 plus or minus root 14 over 2. Let me group all the answers together. I've got 9. I've got negative 2 plus or minus root 14 over 2. By the way, there's one last thing we'll deal with in this unit after today, and that is, well, how do we do this if I just don't tell you an initial solution? How can you find an initial solution and then get the other solutions? That's what we'll look at in 5.8. Last thing we're going to do, though, finding x-intercepts. I want the x-intercepts of this polynomial function if I tell you x equals 4 is a root or an x-intercept. This is no different than what we've already been doing. X-intercepts, remember, just come from plugging in 0 for y. So it's like saying, let's solve the equation 0 equals x cubed minus 37x plus 84 if I tell you x equals 4 is a solution. So let's divide. 4 in the box, 1. Oh, don't forget about the 0 for the x squared term. Negative 37, 84. Here we go. Down 1, up 4, down 4, up 16, down, I think, negative 21, up negative 84, down 0. I'm going to get x minus 4, because that's how I got 4 as an answer. And then x squared plus 4x minus 21. I guess we could say this is y equals, because it was a function. I think you can probably finish this. Keep factoring, and then give me the roots, give me the zeros, give me the x-intercepts. That should be your factoring. It's now a factored form polynomial function, so x equals 4, negative 7 or 3. I guess I wasn't clear if I wanted coordinates or not, so I guess otherwise I would take that. Otherwise, give me 4, 0, negative 7, 0, and 3, 0. So by now, we know how to figure out if something is a factor. We know how to take a factor and find all the factors. We know how to take an answer and find all the answers. We just have to figure out what if I don't give you something to start with. That'll be tomorrow.